Good morning, student. In our last class from the chapter application of derivatives, mainly there we have complete 6 questions from the exercise 6.2. Now today we have to start the next question, which one is question number 7, and the question number 7 is given in such a way that if you see here log of 1 plus x minus twice x divided by 2 plus of x, and here what you have to do, we have to find out the interval here, isn't it? So in this case, first of all, the method already we know what you have to do. First of all, we have to define set the result, and then from there we have to find out the value of x, and then if we put this x values or the critical points on the number line, so easily we can find out the interval. And the question is given y equals to, this one is y equals to log of 1 plus of x, so log of 1 plus of x minus this one is given here twice x divided by 2 plus of x. So this one is the question, and the condition is given here, x value is always greater than minus of 1. So first of all, what you have to do, we have to define set this result with respect to x. Now if you define set this one with respect to x, so define set in this one with respect to x, so dy dx equal to this one we get. So here we have to apply the ddx of log x formula, is not it? ddx of log x is what? 1 by x, so that's why we have to write this one is 1 by 1 plus of x, we have to write minus. Now it is of the form u by v form, so u by v form, so that's why ddx of u by v means what? Denominator whole square, that's why we have to write here 2 plus of x whole square, then here we have to write this one is 2 plus of x into ddx of the numerator is what? Twice x, so that's why we have to write this one is twice x. Is it clear? Then next what you have to do, minus of this one, we keep this twice x, and then we have to write ddx of the denominator, and the denominator is how much here? 2 plus of x. So we have to define set like in this way. So here ddx of log x 1 by x form, and this one is the form of u by v, so that's why we have to apply u by v form. So from here what we get, this one we get here 1 divided by 1 plus of x minus of this one is, if you see here, this one we write 2 plus of x whole square, so 2 plus of x whole square we write, then here you see 2 plus x we keep same, ddx of twice x means what? 2 constant terms, so ddx of x is 1, isn't it? So that's why we have to write simply here 2 into 2 plus of x minus of, now in this case you see here twice x, ddx of 2 constant term 0, ddx of x is 1, so 0 plus 1, ultimately what we get here, the result twice x, so that means we have to write this one is twice x. Now if you see here this one, so twice x, 2 into x, twice x minus twice x, so these two are cancelled. So after that if we take LCM, now if we take LCM, now this one we get here 1 plus of x, and this one we write here 2 plus of x whole square. So if we take LCM, this one is the result we get here. So here we have to write this one is 2 plus of x whole square minus of here twice x cancel, so what will remain here? 2 to the 4 into 1 plus x, so that's why we have to write here 4 into 1 plus of x. Is it clear? So in this case we write here 2 plus of x whole square minus 4 into 1 plus of x. I think all of you understood this one. Now the next step, if you calculate, then dy dx, so dy dx equals to, if you calculate this result, then what we get? The denominator part remains same, so that's why we have to write this one is 1 plus of x, and this one we write here 2 plus of x whole square. Is it clear? So in the numerator it is of the form a plus b whole square form, is not it? So that's what you have to write. This one you have to write 4 plus 4x, 2 to the 4x plus of x square, and minus of, in the second part what will remain here? Minus 4x, this one minus 4x. Is it clear? So now if we calculate this one, you see here 4 minus 4 cancel, and similarly plus 4x minus 4x cancel, so what will remain here? Simply remain here x square. So that's why we have to write this one is x square divided by 1 plus of x into 2 plus of x whole square, and this one is dy dx. Is it clear? So the value of dy dx we get here, dy dx means also we can say this one is f dash of x, is not it? So this one is the value of dy dx we get. After dy dx value here, next what you have to do, now we have to find out the value of x. So for that reason what you have to do, now dy dx, so that means we have to write here dy dx, so dy dx equals to, we have to write 0. So if dy dx equal to 0 we write, so already we know the value of dy dx, so dy dx is how much here? This one we have to write x square, and here we have to write this one is 1 plus of x and into, and now here this one is we write 2 plus of x whole square equals to 0. Is it clear? So now here x square 1 plus of x 2 plus of x whole square we write equals to 0. So now in this case if you see here, so this denominator easily we can cross multiply with 0, then we get ultimately from here what we get, the value of x equals to, we get here 0. Is it clear? So the value of x is here 0. Now in this question, if we see at starting the condition is given x is greater than minus 1. So x is greater than minus 1, through its domain we have to find out the interval here. So that means at starting already mentioned here x is greater than minus 1. So that's why when we have to find out the interval here, now if you see the graph, so the points are already mentioned. So the graph is mentioned from where to where, x is greater than minus 1. This one is a condition given. So that means x is greater than minus 1 means the interval is from minus 1 to up to plus infinity. Here it is not minus infinity to plus infinity, because here already the condition is mentioned, x is greater than minus 1. So greater than minus 1 means up to plus infinity. So in between minus infinity to plus infinity, so there a critical point we get, and which one is 0. So we have to put this one is here 0. So now if you see here, we get two intervals. Now after plotting 0 we get two intervals. One interval is from minus 1 to 0 and the another interval is from 0 to infinity. Is it clear? So one interval is from minus 1 to 0 and another one is 0 to infinity. Now in this case we have to check out in which place it is increasing or at which place it is decreasing, we have to identify. So here in earlier class, in our last class, we know what we have to do. We just take a point in between these two and just we have to put this point where, on the dy dx value or in f dash of x. So if we get the value is greater than 0, then it is increasing, or if it is less than 0, then it is decreasing. So if we check out any value here from 0 to infinity, any value, suppose we take 1, in between 0 and infinity, if we get 1, if we assume 1, so if we put here 1, you see 1 square, 1 plus 1, 2 plus 1. Ultimately, this one is what? A positive value or not? So we get a positive value. That means from here what we can say? From 0 to infinity it is increasing. Now here another method is there. With the help of this one also we can prove this result. Now let's say here. The interval is from where to where? The x value is lies between minus 1 to 0 and here 0 to infinity. Isn't it? Two intervals we get. So this interval is actually we write here from where to where, minus 1 up to 0, open interval, is not it? Disjoint interval, so that's why minus 1 to 0 and 0 to infinity. So this one also we can write in this way, the value of x is greater than minus 1, the value of x in between from minus 1 to 0, this part is, if we assume x, then the value of x is greater than minus 1 but less than 0. If we write here, the condition we get like in this way. So in this case, if you see the interval is from 0 to infinity, is not it? And now in this case what we write, the value of x is greater than 0. 0 to infinity means what? Easily we can write the value of x is what? Greater than 0. And in this case what we write? The value of x is lies between minus 1 and 0. Now with the help of these two conditions, now we have to prove whether it is increasing or decreasing. This one is another method here. From here also we can prove this result. Is it clear? Now let's see. So here first of all, if you see, so these results are totally depending on dy dx. What is the dy dx value? So dy dx value, what we get here, dy dx equal to, already we get x square divided by 1 plus of x into 2 plus of x whole square. Is not it? This one is the dy dx result. So if we check out this one more time, so dy dx, so dy dx equals to what? Dy dx equals to, we get the result is x square, this one is 1 plus of x and this one is 2 plus of x whole square. So this one is the main part here. So this result, how can we rearrange here? First of all, if you see this part, if you see now for the first part, for the first interval is from where to where? Minus 1 to 0. So in this case, if you see here, the first condition is here, if separately if we draw, x is less than 0. If you see this part, x is less than 0. If we squaring both sides, then x is less than 0 means what? A negative value. And if we square the result, then what we get? Suppose any value, if we consider suppose minus 5, if squaring, then what we get? So obviously 25, that means a positive value. So if we square, then the value is must be greater than 0. Eto buji pala na sabe? X or value to 0 ke horu asile, kintu jetia ami square kori dilo, squaring kori dia matrake he value to ki hobo? 0 ke ki hoy jabo? Dangor hoy jabo. So why we have done this? Why we do square? Because in the result we need x square, so that's why we have to squaring this one. Is it clear? Okay, next condition. If you see this next condition here, second one is here, and second condition is here 1 minus of 1 less than x. So adding 1 on both sides, that means 0 is less than 1 plus of x here. That means 1 plus of x. That means what is the meaning of this result? That means the meaning is this one, 1 plus of x value is greater than 0. If 1 plus x value is greater than 0, so if we add another 1 here, yeah, jodi aru ami 1 eta plus koi dio, 2 plus x koi dio, then obviously it is greater than 0, is not it? Since 1 plus x is greater than 0, 1 to thakunte greater than 0 hoise, titale 1 otke dangor jodi 2 jodi put koi dio, titale greater than 0 hobo nai. So obviously, so therefore from here what we can say, therefore 2 plus x is also greater than 0. So why we have done this one? Don't confuse here. Here ami 1 to both sides add kora nai. Here a 2 je likhilu, eto 1 to both sides add kora nai. Add kora hole it implies likhilu haten. But what we write here? We write 2 plus x. So therefore 2 plus x. That means if the value 1 plus x is greater than 0, so automatically 2 plus x is greater than 1 plus x or not? If 2 plus x is greater than 1 plus x and 1 plus x is greater than 0, that means from here easily we can say 2 plus x is automatically greater than 0. So 2 plus, if 2 plus x is greater than 0, this implies their square is obviously greater than 0. So 2 plus x square is greater than 0 here. Is it clear? Understood this one? So why we have done this one? If you see the question, x square, 1 plus x, 2 plus x whole square we need. So now if you see here, x square is greater than 0. At first we get 1 plus x is greater than 0. And now here, the third one is we get here 2 plus x is also greater than 0. So if you see these three results, x square is greater than 0, 1 plus x is greater than 0, and 2 plus x square is also greater than 0. That means all these three are what? Positive value here. So that means this one is greater than 0, this one is greater than 0, this one is greater than 0. If these three are greater than 0, if these three are greater than 0, then what we can say here? dy dx value is greater than 0. If dy dx value is greater than 0, then what we can say? It is strictly increasing on minus 1 to 0. Is it clear? So this one is another method here. Or you can directly put here point and then also you can find out here. So finally what you have to write down the conclusion here. Therefore we write here x square 1 plus of x, and this one we write 2 plus of x whole square. All these three values are greater than 0. Reason behind this one is greater than 0, greater than 0, greater than 0. So as a whole this whole result is what? Greater than 0. If this whole result is greater than 0, so in place of this one we write here dy dx is greater than 0. If dy dx is greater than 0, that means what is the meaning of this one? So therefore we can write down the conclusion here minus 1 to 0. The function or y is what? Y is at interval minus 1 to 0. The interval is what? Strictly increasing. Is it clear? So this one is the first proof here. First part. And another interval is here. Another interval is given from where to where? 0 to infinity. Now next we have to do this one. So the next interval is from where? 0 to infinity. So 0 to infinity. So in this case what you have to do? Let's see here. Obviously the condition we get here. Therefore we get the condition is x is greater than 0. Is not it? So here if x is greater than 0, so easily we can say here x square is greater than 0. Is not it? So if x is greater than 0, so obviously x square is also greater than 0. Is not it? So now here one more thing here, if you see, already we prove x is greater than minus 1 and that means x plus 1 is greater than minus 1, already we proved. Similarly 2 plus x whole square is also greater than 0, already we proved. All these three are we proved or not? Here we get x is greater than 0, that means x square is greater than 0, we get here. And the other two are 1 plus x greater than 0, already proved in the earlier one. Similarly 2 plus x whole square greater than 0, already we proved in the earlier interval. So in this case we can directly write, so therefore what we write here, without doing anything, we can directly write x square plus 1 plus x and 2 plus of x whole square. So 2 plus of x whole square is greater than 0. That means all these three results are greater than 0. So that means dy dx. So dy dx is greater than 0. So from here what we can say, in the interval 0 to infinity also the function is strictly increasing. So here in 0 to infinity it is strictly increasing, as well as from minus 1 to 0 also it is strictly increasing. Which one we need to prove here? Is it clear? So here the question number 8 is given, y equals to x into x minus 2 whole square, isn't it? So this one is a very simple question. This type of question, lots of questions are we have done in our last class, isn't it? So in this case what you have to do, first of all, if you see the function y equals to, here given this one is x into x minus 2 whole square. So if you break this one, then here what we get, this one we get here x square minus twice x whole square. So no need to break this one into whole square form. So just keep like in this way. Now we have to differentiate this result. So therefore dy dx. So therefore dy dx equals to what you have to write. It is of the form x square form. So that's why we have to write 2 into x square minus twice x. Isn't it? ddx of x square form. So ddx of x square means twice x. So 2 into x. Using the chain rule we apply this method. So now here, but this one is not x, so that's why again we have to differentiate this one. So ddx of x square, what you have to write? Twice x, and ddx of twice x means what you have to write? Minus of 2. I think all of you understood this one, isn't it? So this result we get here. Now after that what you have to do? Now dy dx equal to, so from here we have to find out the critical point. So that's why dy dx. So dy dx equal to, we have to write 0. And this implies dy dx means here this one is 2x square minus of twice x, and this one is twice x minus of 2 equals to 0. And now from here if you see here 2 is not equal to 0, isn't it? If 2 is not equal to 0 here, either this part is equal to 0 or this part is equal to 0. So therefore what you have to write? Therefore we have to write here x square minus of twice x equals to 0, or the second part, what you have to write? Twice x minus 2. This one you have to write, or twice x minus of 2 equals to 0. These two possibilities are there because 2 is not equal to 0. So now if you see the first one, so from here the first one what we get? If you see this one, x square minus twice x equal to 0. So from here what we get? If we take x common, then here remain x minus 2 equals to 0, isn't it? Or in the second part, in this case if you see here, what is common? 2 is common. So if we see here 2 is common, so what you have to write here? X minus of 1 equals to 0. And from here therefore what we get? We get two values here, either x equal to 0 or x equal to 2. So either x equal to 0 or x equal to 2, we get two results here from here, isn't it? And in this case what we get? 2 is not equal to 0, only the possibility is what? X is equal to 1. So therefore from here what we get? We get the value of x is equal to 1. So how many x values or critical points are we get here? 0, 1 and 2 in the number line minus infinity to plus infinity, isn't it? So these three critical points or these three x values are we have to put on the interval number line, and after that we have to find out the interval and we have to check out in which part it is increasing or decreasing. So what you have to write? After getting the critical points here, if you plot the points on the number line, so that's why you have to write this one is minus infinity plus infinity, and the critical points are 0, 1, 2 and 3. So that's what we have to write one by one. 0, 1, 2, 0, 1, 2. These three are the critical points we get. So from here lots of intervals we get. If you see minus infinity to 0, 0 to 1, 1 to 2, 2 to infinity. So I think all of you know what you have to do here, isn't it? So first of all, if we check out for the first interval, the first interval is from minus infinity to 0. If you check out here, minus infinity to 0. If you check out here, in this case what we get, dy dx value is, so what is the value of dy dx? So dy dx value is this one, 2 into x square minus 2x, x minus 2, is that it? So if we check out again one more time, so dy dx value is actually this one, dy dx equal to what we get, 2 into x square minus twice x into twice x minus 2, twice x minus 2. This one is actually the dy dx value, is that it? So this one is the dy dx value here, and now here in between minus infinity to 0, any one point we have to put here, and after putting this point, any one point from minus infinity to 0, that means any negative value we have to put here, and let's check out whether it is increase or decrease. Similarly, the next interval is from 0 to 1, and 0 to 1, any point in between 0 to 1 we have to put here, and let's check out, calculate whether it is increase or decrease. Similarly, from 1 to 2 we have to put any point and plot here, and let's check out. And in this way, the last one is 2 to infinity, and we have to plot. And in which place we get increase or at in which place we get decrease, this task is yours. You have to calculate this result, and from here you have to identify the interval at which place it is increasing or at which place it is decreasing. Is it clear? So mainly these two questions are we have done today here. So in our next class we have to continue this exercise. So this exercise or the chapter increasing and decreasing function, this one is very important examination point of view. So that's why each and every question you have to do very carefully and properly. Is it clear? So practice is very important here. So you have today you have to calculate these results, and let's check out what we get here. Is it clear? So in our next class we have to continue this exercise. Is it clear? Okay, thank you.